Hey all you cool sabers, today we're going to take a look at angle theorems. So the first thing we're going to do is we're going to talk about some definitions here. And the first one is a line, and I'm sure that you all know what a line is, but what's important here, and I drew that perfectly straight as you can see, but what's important here is that when we talk about a line in math, it goes forever in both directions. And so we put these little arrows on each end of the line to show that it continues forever. So our description will be, and I realize the irony of using the word line in my description of a line, but it's a line which extends infinitely. I'm going to zoom in so I can make this a little neater. Infinitely. Oh, you should spell infinite, right? Infinitely. Nope, I'm way off. No, that's right. There we go. Okay. Infinitely in both directions. In both directions. Okay. Oh, that was high. So that's what a line, yeah, so like I say, what's important here is that when we talk about a line in math, it goes on forever. A line segment, on the other hand, is going to be exactly the same thing, except we put little circles on the end like this to show that it has a beginning and an end. So it has two endpoints. So it's a line with two endpoints. Oh, that's not how you spell end. Two end points. All right, it has a beginning and an end. I should erase that little scribble. Perfect. Okay, so that's a line segment. I mean, you could kind of figure that out from the name. It's a segment of a line. So next we go on to ray. So a ray has a beginning but no end. All right, it has one endpoint and then extends infinitely in one direction. So, a line. I just spelled the word line wrong. I'm not doing well today. Spelling doesn't matter. This is math class. That's why I put an E on the word with just now. Oh my God, I'm a disaster. All right, with one endpoint. A line with one endpoint. Okay, a line with one endpoint that extends infinitely in one direction. That extends infinitely in one direction. All right, so that's that. So let's take a look at parallel lines. So, I'm sure this one's not new for you. So parallel lines, whoosh, whoosh. Again, my perfectly straight lines here. We got two lines and they just never touch. So two lines which never touch. Okay, they'll go on forever and ever and ever and ever, and they'll never touch. Okay, perpendicular lines. There's our first line, then our second line. Okay, so we got two lines here, and these ones, they meet at a 90-degree angle. Okay, so two lines that meet at 90 degrees. All right, or a right angle, if you will. Okay. An acute angle. So if we're talking about an acute angle, got any angle like this, okay? This angle like this, and what's important is that it is less than 90 degrees. An angle less than 90 degrees. And a right angle. I mean, I guess I already said this when we talked about perpendicular lines, but a right angle, which we denote with a little square there, is an angle of exactly 90 degrees. All right. Okay, so let's jump down. I'm sure you can figure out obtuse angle at this point. Well, maybe not completely, but anyway, we got, well, you should know most of these at this point. Okay, well, there's our angle right there. So it is an angle, and it is between 90 degrees and 180 degrees. Okay, so it is important that it is less than 180, but it is greater than 90. All right. A straight angle is one that you don't often talk about because it doesn't come up that often. All right, it's actually this angle here, which of course is 180 degrees. So an angle of 180 degrees, and it's called a straight angle because of course an angle of 180 degrees is just going to make a 90 or a straight line, a 90-degree line, a straight line. Okay, so a reflex angle, this one not everybody will know, but it's this angle here. It's an angle greater than 180 degrees. It's the angle on the outside. So an angle greater than, I'm getting real messy here. Oh, no, it's not even working. Let me try that again. Greater than 180 degrees. All right, and finally, an angle bisector. So if we've got, we'll just start by drawing our angle. That's our angle right there. Okay, and the angle bisector is this guy right here, okay, which cuts it exactly in half. So this is a line or ray. I'm just going to say an align, but it could be a ray. No, I did just start. After I said that, I just started writing or ray. Okay, which divides an angle exactly. Well, that's not how you spell exactly. Exactly in half. All right. Well, there we go. Not bad. I think that, oh no, that's not it. There's still more. Whoops, oh, and I'm just gonna, if I can figure out how to switch to the next page, oh, there we go. All right, so let's talk about the actual angle theorems. So, let's see, hold on, sorry. Oh, I can't get, okay, whatever. Okay, complementary angles are angles that when you stick them together, they add up to 90 degrees. All right, so for instance, we've got x and 25. We put them together, they equal 90. So you say, wow, what's 90 minus 25? So x is going to be 65 degrees. Right, 65 plus 25 equal 90. Alternatively, if we had one here, this angle x, which is going to add up with 40 to give us, hold on, I feel like my formatting's all off here. It doesn't make a difference. X here, I'm just going to label it like this. That is going to be 50 degrees because it adds up with 40. So I guess that actually was, I did put them on the right blanks, kind of. It's just, whatever. All right, anyway, supplementary angles. These are angles that add up to 180 degrees. So when you stick these ones together, they make a straight line. And then you're much more likely to deal with supplementary angles. They come up over and over and over and over. Over and over and over. So for instance, this one here is going to be 135 degrees because if you add 45, you'll get 180. Okay? And over here, we've got 95, which to get 180, you would need 85 degrees. All right? Let's see, so reflexive angle theorem, or RAT, which to be honest with you doesn't come up that often, but if we add two things to get 360 degrees, it gives us the, so you're looking at the reflex angle associated with the angle. So for this one, it would be this angle here, okay? So it would be 100, or it'd be 360, okay? We've sort of cut out 67 degrees, which is going to leave us with 293 degrees. All right, is that right? Yes, that is right. Okay, anyway. And then we've got QRT here. So again, we're looking at this outside angle right here. Okay, if you've got one like this where there's multiple angles in there, you can just do, there's a couple ways you can do it. You can do the 360 and subtract 45 and then subtract 35. Or if you prefer, you could say, what's 360 and then subtract, and then just say, well, what's 45 plus 35? So that'd be 80. Okay. And then it doesn't matter if you, whether you go straight from this guy right here or from this one right here, it doesn't make a difference. It's the exact same thing. Either way you look at it, you're going to get 280 degrees. All right. And that's that. So can I, successfully turn the page the first try of this one. All right, opposite angle theorem. This is another one that comes up a lot more than some of the others. Supplementary angles, opposite angle theorem. These are ones that come up quite a bit just in general math, whether you're doing a geometry unit like this or not. Regardless, the idea here is that if you've got two lines that create an X, like we have here, the angles that are opposite each other or across each other from each other are equal. So fortunately, this one's actually pretty easy too. So DEC, remember, if you're given an angle like this, it means you start at D, you go to E, you go to C. So we're talking about, no, I didn't draw the C. Okay, so we're talking about this angle right here for this one, okay? And it's opposite from that 50 degrees, so it is also 50 degrees. Which BEC, going from B to E to C, okay? It's going to be the same as the 130. All right? Not too challenging, although hopefully your diagram is better than this one. That 35 degrees is supposed to be right there, which means RSQ, R to S to Q is also going to be 35 degrees. And then P to S to R is going to be 145 degrees. All right, so there's no actual calculation on those ones, which is kind of nice. Let's see. Oh, and then we got our Z pattern, F pattern, C pattern. These ones are fun. Okay, if you've got the Z pattern, which is sometimes called alternate angles, that's what it's really called, but nobody calls it that. Everybody calls it Z pattern. It just means that if you've got an angle in like there and an angle in there, they're going to be equal to each other. Okay, for the F pattern, it's when you have an angle in there and an angle in there that the angles are also equal. And then not quite as easily, but if you have an angle in here and then another angle in here, those two angles are going to add up to 180 degrees. All right? Okay, so, oh, and I guess I should look at this. I just skimmed over here. So the line that goes through the two parallel lines is called a transversal. So if you see the word transversal, that's what it means. It means you got two parallel lines, and you just draw a line straight through it. Okay? And yeah, and we get these chevrons here, right here. Those just mean that the two lines are parallel. This one's doubled up. It doesn't necessarily have to be double like that. As long as they're like that, that's what it means. Okay? So, let's take a look here. So this tells us what angle 1 is equal to and what angle 12 is equal to, and we're going to figure out all of the angles. So the easiest way to do this is to say, okay, so I know angle 1 is equal to 115 degrees. Well, that means that angle 6 is also equal to 115 degrees, and that's not actually on there. Why are there M's? I don't know why there's M's. Anyway, whatever. It doesn't matter. So 1 and 6 are both 115, but you can use your Z pattern to see that angle 9 is also, or your F pattern. F pattern with the 1 and 9, Z pattern with the 6 and 9 to see that the 9 is the same and the 14 is the same, just from opposite angles there. Okay, so we'll go through 1, 6, 9, 14. Do we have that? Yeah, we got 9 right there, so that one's 115. Do we have 14? We do. 14 is over here, so that's 115. Okay, and I think that's it. Is that it? One, two, as I don't see a 6 or, yeah, all right. So then let's take a look here. That tells us that angle 2, 5, 10, and 13 are all also going to be the same. So as long as we can figure out one of those, we can figure out the rest. So you can see that angle 1 and 5 are supplementary angles. So they're going to add to 180. Alternatively, you could say, well, 5 and 9 make a C pattern, so they're going to equal 180. The 6 and 10 make a C pattern, they're going to equal 180. Either way, it's going to equal 180. Okay, so let's see. So we got, what was it? It was 115. Okay, so we're going to have 65 is going to be our other angle. So 2, 5, 10, and 13 are all just going to be 65 degrees. So let's see. So do we have 2, 5? I see a 5 here, so that's going to be 65. All right. Is there 2, 10, or 13? 2, 10, or 13? I don't see a 2, 10, or a 13. So I guess we're off the hook. All right. So next, let's take a look here, and we have. Let's start with angle 3. So angle 3 right there. Angle 8. Oh, I shouldn't have done 3. I should have done whatever. It doesn't matter. 11 and 16 are all also going to be the same, as well as 4, 7, 12, and 15. So it gives us 12 is 110. So that tells us that 15, which is not asked, 4 and 7. I see 4, so let's see. So that'll be 110. And then 11, 11, 8, and 3 are all the same. So the only ones that are left to ask are all those red ones. They have to add up to the 110 to give a... So, wait, where's angle 10? Oh, angle 10, no, that's... Forget that one. This one is 70, this one's 70, and this one's 70, which leaves us with, yeah, this angle 10 I missed, which was 65. All right, that's it. I kind of rambled there at the end there, but you get the idea. Until next time, go Sabres.